So I want to really briefly give you a fact. AB transpose. So the transpose of the product AB. Guesses? If this was algebra class, what would it be?
A transpose B transpose. Yeah.
Perfect. There's absolutely no justice in this world, and so this is the right answer. You need to do this. What does that mean? Yeah, it's going to be B transpose A transpose. I'm gonna leave this kind of without much proof, but I'll give you a little sketch of where you could get this from. Just heuristically, if you have A that's, say, m by n, and you can multiply it by a matrix B, what do I know about this matrix B?
It's gotta have n rows.
Yeah, it's n by something. So I'm gonna call that n by p, I guess. And then if I think about B transpose, how big is B transpose? So B transpose then is going to be a P by N matrix, and A transpose is going to be how big?
N by N matrix.
Perfect. N by M. And so if I'm going to have any hope of multiplying these together any damn ways, it's going to have to go B transpose first, then A transpose. This is not a proof, right, of that fact, but this is a proof of the idea that it shouldn't necessarily be A transpose, B transpose. Right? I should be able to really easily construct a counterexample, because I can make that thing not even make sense. You guys see that? So we can really quickly decide on this that it's not A transpose, B transpose in general. Does that say it's never A transpose, B transpose?
No. Oh, no.
No, it certainly could be. You guys got an example for me of two matrices?
Like if they're both 3 by 3.
They're both square.
Yeah, if they're both the identity matrix. In the case that they're square, it's not necessarily a guarantee,
They gotta be the
right?
same square.
But it's possible.
Yeah, they're all one.
If they're the same matrix, that'll certainly do it. Identity is a good thing to tick. The other good place to explore for an example would be the zero matrix. Like if they're both the zero matrix. You guys kind of with me on that? Okay. So in order to actually prove this, the kind of proof sketch that you, or the hint I'm going to leave on the video here, is make A and B something, and write down first things first all the rows of A. So A is going to have some rows. In the end, how many rows is A going to have? Based on the size I gave it earlier.
M rows.
It's going to have M rows. And then make yourself B. And because I'm considering rows of A, I'm probably going to consider columns of B. You guys with me on that? So draw yourself the columns of B. How many columns is B going to have?
P.
P column.
Perfect. It's going to have P columns. And then compute yourself AB. You guys with me on that? Okay, so if I compute myself AB, I'm going to pick columns up and drop them onto A, right? So this first column in AB is going to be the matrix A done to the first column of B. So that's going to be row 1 dot column 1, right, where row 1 came from A and column 1 came from B. And then we're going to have all the way down here What's the last one gonna be?
Row M, column P.
That's gonna be the one way down here.
Oh, darn. Row 1, column P. No. Row M, column.
Good, it's row M dotted with column 1.
Yes.
You guys see that? In the top right corner, I said I was just gonna sketch this proof, no, I'm just doing it.
Row 1 dotted with column P.
You're gonna have row 1 dotted with column P, and down in the bottom corner here,
Or, okay, column P.
perfect, row M dotted with column P. Guys with me on that? So that's the matrix AB. If I transpose that matrix AB, right? And then if you transpose the matrix A, the rows turn into columns. If you transpose the matrix B,
Columns are rows.
columns turn into rows. Then you can compute this product, you'll see that you get the same thing. Good with that?